So what is object-oriented programming? Object-oriented programming is a programming paradigm or a style of programming that is centered around objects rather than functions. It's nothing new, it's been around since the 70s, but unlike tools and frameworks that come and go, object-oriented programming is still very relevant today. That's because it's not a programming language or a tool. It's a style of programming or a programming paradigm. There are several programming languages out there that support object-oriented programming, such as C#, Java, Ruby, Python, JavaScript, and more. Now, JavaScript is a little bit controversial, but I'll get to that later. It may interest you to know that many of the popular frameworks out there that you might be using are actually designed with object-oriented programming concepts in mind. Angular is an example of these frameworks. So object-oriented programming is a very popular style of programming, and it comes up in many technical interviews. So if you really want to be a serious developer, you need to understand object-oriented programming. As a technical interviewer myself, if I see a candidate with object-oriented programming on their resume, that candidate stands out to me. And that's where this crash course comes in. In this course, you're going to learn and understand object-oriented principles and how to implement them in JavaScript. My name is Mosh Hamedani, and I'm going to be your instructor in this course. If you enjoyed this video, please like and share it with others. And be sure to subscribe to my channel for new videos every week. You can also follow me on Twitter as Mosh Hamedani. So now, let's get started. A popular interview question concerns the 4 core concepts in object-oriented programming. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you will learn as part of your first programming subject at a university. But as your programs grow, you will end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function and then several other functions break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like setItem and removeItem. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have 3 variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side. They are decoupled. Now let's take a look at the object-oriented way to solve this problem. We can have an employee object with 3 properties: base salary, overtime, and rate, and a method called getWage. Now why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our getWage function has 3 parameters. The reason in this implementation we don't have any parameters is because all these parameters are actually modeled as properties of this object. All these properties and the getWage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside. All that complexity is hidden from you. This is abstraction in practice. We can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits. First is that we'll make the interface of those objects simpler. Using and understanding an object with a few properties and methods is easier than an object with several properties and methods. The second benefit is that it helps us reduce the impact of change. Let's imagine that tomorrow we change these inner or private methods. None of these changes will leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, we reduce the impact of change. Now, the third core concept in object-oriented programming: inheritance. Inheritance is a mechanism that allows you to eliminate redundant code. Here's an example. Think of HTML elements like text boxes, drop-down lists, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of redefining all these properties and methods for every type of HTML element, we can define them once in a generic object, call it HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundant code. And finally, polymorphism. Poly means many, morph means form. So polymorphism means many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. But the way each element is rendered is different from the others. If we want to render multiple HTML elements in a procedural way, our code would probably look like this. But with object orientation, we can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object we are referencing. So we can get rid of this nasty switch and case and use one line of code like this. You will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of a program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor ugly switch case statements. To go through this course, all you need is a code editor and a simple web server. The editor that I'm going to use here is Visual Studio Code or VS Code that you can download from code.visualstudio.com. But feel free to use any editors. Now, with VS Code, we have this extensions panel here. Search for Live Server. This is a very simple and lightweight server that we're going to use to serve our application. So install this, and then here in the Files panel, let's add a new file, index.html. Now, to generate some basic HTML template, we can simply type an exclamation mark and press Tab. So a very basic HTML template. Now let's add a script element. So script with source set to index.js. We're going to write all our JavaScript code inside of this file. So Let's add a new file and save it as index.js. And finally, to make sure that we have set up everything properly, let's do a console.log of hello world. Now, when you install Live Server, you should get this menu here in the status bar. If you don't see that, you probably have to restart VS Code. And if you still don't see it, simply right-click on index.html and select Open with Live Server. So this will fire up Chrome, pointing to this address. Now, let's open up Chrome Developer Tools. Here in the console tab, we've got Hello World. So, before going any further, I want to emphasize that this course is not for beginners, it's for intermediate level developers. So you should have at least 3 months of experience programming in JavaScript. You should know the basics, you should know how to use Chrome Developer Tools. I'm not going to cover these in this course. Our focus is purely on object-oriented programming with JavaScript. JavaScript is all about objects. So in order to learn object-oriented programming, first you need to have a good understanding of objects. So in this section, I'm going to cover some fundamental concepts around objects, such as creating objects, factories and constructors, primitives and reference types, and how they behave differently, working with the properties of an object, such as adding, removing properties, as well as enumerating them. You're also going to learn how to define private properties, as well as getters and setters. If you know all these topics well, feel free to skip this section and move to the next section where I talk about prototypes. Otherwise, continue watching. So now, let's get started. Let's start this section by creating an object. So I'm going to use the let keyword in ES6, which is the replacement for var. So in ES5 and before, we had var for declaring variables, but var has a number of issues when it comes to scoping. That's beyond the scope of this course. I just want to let you know that as a best practice, stop using var. Use either let or const. With const, you're basically defining a constant, so you won't be able to reassign it. If you want to reassign a variable, use let. Now in this demo, I'm going to use const to define a constant. So let's call this circle and set it to an object. Here I'm using object literal syntax. So these curly braces, we refer to them as object literal syntax. An object in JavaScript is essentially a collection of key value pairs. So inside these curly braces, I'm going to add a few key value pairs. Let's add radius and set it to 1. Let's add another key like location. Now this time the value can be an object. So again, I'm using object literal syntax. In this object, we can have a couple key value pairs like x and y. Now let's add another key value pair. So the key is draw. The value is a function that is for drawing the circle. So for now, let's just do a simple console.log. Now I want to define a few terms here. This circle object has 3 members: radius, location, and draw. If a member is a function, we refer to that as a method. So here we say draw is a method. These other members are what we call properties. Now in some JavaScript tutorials, they refer to all these members as properties, whether they're functions or not. But technically in object-oriented programming, properties and methods are fundamentally different because a property is used to hold values. A function or a method is used to define some logic. So now that we have this circle object, we can access its members using the dot notation. So circle dot, look, here are the members. We can call the draw method. Now note here on the right side, I've got Chrome open. This is Chrome Developer Tools. As soon as I save my changes here, you will see that Chrome is going to refresh because here with Live Server, we have hot reloading. So save, and here's the result. So as soon as we change our code, the new code is loaded inside Chrome. So object literal is a simple way to define an object. But we can also define objects using factories and constructors, and that's the topic for the next lecture. Now let's imagine we want to create another circle. With the current implementation, we have to duplicate all this code like this. Now, this can be a problem if we have one or more methods in our object. In this case, we have this draw method here. And as we can see, we have duplicated that in two different places. So if there is a bug in this method, we have to come back and fix it in multiple places. Now, this is a very simple object. Imagine if the circle object had 10 methods. So object literal syntax is not a good way to create an object and duplicate it if this object has at least one method. If an object has one or more methods, we say that object has behavior, like a person that can do different things. So it has behavior. Now let's imagine here we didn't have this draw method. Duplicating this object wouldn't be a big deal. So basically we would end up with two objects, and then here we could use different values. So creating objects with the object literal syntax is an issue only if that object has behavior. So what's the solution? The solution is to use a factory or a constructor function. So let me show you how that works. I'm going to delete this second circle and define a function called createCircle. Now I'm going to move all this code inside this new function, like this. Now we don't need to declare a constant, we can simply return this object. Now this circle requires a radius, so instead of hard coding 1 here, I'm going to add a parameter here, radius, and then set that here. Now in ES6 we have this new feature, so if the key and the value are the same, we can remove the noise in the code by removing the value. So we can only add radius. Now to simplify the code so you can focus on what I'm going to teach you, I'm going to drop this location property. We don't really need it. Instead, I'm going to add our draw method. So key, value, and let's do a simple console.log draw. Okay? So this is what we call a factory function. Now, we can simply call this function to create a new circle. So constant circle, we call create circle and pass 1 as the radius. Now there is another way to create an object using a constructor function. So let's delete circle.draw and define a constructor function. I want you to see them side by side. So once again, we define a function, but the naming convention we use for a constructor function is different. The first letter should be uppercase. So we call it circle with an uppercase C. To developers with background in languages like C# and Java, this kind of looks like a class. However, as you can see, we're defining a function. In JavaScript, we don't have the concept of classes. So our circle function is going to take a radius parameter, but in the body, instead of returning an object, we're going to use the this keyword to set the properties of this object. What is this? This is basically a reference to the object that is executing this piece of code. You're going to see that in a second. So imagine we have a new empty object in memory. Now we're going to use this to reference that object and then use dot notation to set various properties on that object. So we can set the radius property to this radius argument. Similarly, we can define another property, draw, but this is more accurately a method, so we set it to a function. And here we do a console.log of draw. Okay, now we can create a new circle like this. We use the new operator to call the circle function and pass 1 as the argument. When we use the new operator, a few things happen under the hood. This new operator will create an empty object. So like this, an empty object. Then it will set this to point to that object, because by default, this points to the global object. If you're running this code inside of a browser, the global object is the window object. If you're running it inside a node environment, the global object is global. Let me show you. So I'm going to do a console.log of this. Let's see what happens. So save the changes. Now look, this is this circle object here. And here we have two members, draw and radius. This is because we used the new operator here. If I remove that, let's see what happens. So save the changes. Now this references the window object. So this is the global object in a browser. We don't want to use this. We don't want to mess up with this. We don't want to define global variables because they're bad practice, because they're available everywhere in our application. So it is possible that one function or another will modify the value of these variables accidentally and create a bug in our application. So when we use the new operator to call a function, three things happen. First, this new operator will create an empty object. Then it will set this to point to that object. And finally, it will return that object from this function. So note that here, we don't have an explicit return statement. We are not returning this. This will happen automatically when we use the new operator. So let me delete this. Also, we don't need console.log here. So basically, we have two ways to create an object. We can use a factory function or a constructor. There is nothing special about these. They're both regular functions in JavaScript. If we return an object in this function, we refer to that function as a factory function. In contrast, if we use the this keyword along with the new operator, we refer to that function as a constructor function. Now you might ask, what is the difference between these two patterns for creating an object? Which approach should you use? Well, it really depends who you ask. Developers coming from languages like C# and Java prefer the constructor function syntax because this looks like creating an instance of a class. But once again, in JavaScript, we don't really have classes. Other developers don't like this approach. They prefer to use factory functions. And one of their arguments is, what if a developer forgets to use the new operator here? Then we're defining these property methods on the global object, which is in this case the window object. But this discussion, this argument is really outdated. With the modern JavaScript and the tools that are available to us, we get an error if we forget to use the new operator here. So my suggestion to you is not to get hung up on these religious arguments about factories versus constructors. As a developer, you should be familiar with both these patterns because as you work on different projects and different teams, you will see both of these patterns for creating an object. So you should understand how they work. Choose the pattern that you prefer. Every object in JavaScript has a property called constructor, and that references the function that was used to construct or create that object. So here we have two objects, circle and another. Let's look at the constructor property. So here on the console, another dot constructor. So as you see, this returns our circle function that we used to create this object. Now let's look at circle dot constructor. What is this? Well, you can tell that this is a function because here we have this blue F. And as you can see, the first letter of this function is uppercase. So this is a built-in constructor function in JavaScript. When we create an object using the object literal syntax, internally, the JavaScript engine uses this constructor function. Let me show you. So I'm going to temporarily delete all this code. Let's define an object like this. When we use this syntax, object literal, JavaScript engine will translate that to something like this. Let x equals new object. Okay, so this circle object, we created and returned it from our factory function. And because we use the object literal syntax, internally it was created using this object constructor function. In JavaScript, we have a few other built-in constructors. For example, we have string for creating strings, but quite often we use string literals. So single quote or double quote or backtick. Using these literals is cleaner and simpler than using the constructor. We also have Boolean, but again, we don't use this. We either use true or false. So we refer to these as Boolean literals. We also have number, but instead we use number literals, like 1, 2, 3, whatever. So this is what I want you to take away. Every object has a constructor property, and that references the function that was used to create that object. One of the confusing concepts in JavaScript is that here functions are objects. So this circle function we have here is actually an object. Don't believe me? Let me show you. So circle dot, look, these are all the members of this circle function or circle object. So the purple icons are methods like call, bind, and apply, and the blue icons are properties. So let's take a look at a few of these members in the console. Here in the console, circle dot name, that returns the name of this function. Circle dot length returns the number of arguments. Now earlier in the last lecture, I told you that every object in JavaScript has a constructor property, and that references the function that was used to create that object. Now here's the interesting part. Who do you think created this object? Let's have a look. So circle dot constructor. So here we have another built-in constructor called function. And when we declare a function using this syntax, internally, JavaScript engine will use this function constructor to create this object. Let me show you. So I'm going to define a constant called circle1 to separate from our circle. Set it to new function. Now here our function requires one parameter, radius. So we add that here as a string. Now as the second argument, I'm going to pass the code inside of this function. So to break it up into multiple lines, I'm going to use the backtick character and then simply copy all this code and put it here. So when we declare a function internally, it's represented like this. Now we can call this circle1 just like calling our circle function. So we can create a circle object by newing up circle1 and pass 1 as the radius. Save the changes. Now in the console, let's log circle. Look, it's a real circle object with these two members. Now let's take a look at a couple of methods that are available in our functions. So I'm going to delete all this code. Circle dot. Here we have this call method. And with this, we can call a function. Look at the arguments. The first argument is this argument. Here we need to pass an empty object, and this will reference this object that we pass here. Okay? Now after that, we add our arguments explicitly. So here we have one argument, we pass 1. If we had multiple arguments, we would pass them explicitly like this. Okay? So this expression is exactly like the expression on line 11. When we use the new operator, this new operator will internally create an empty object and pass that as the first argument to the call method. And this object will determine the context for this. So this will reference this object. Earlier, I told you that if you don't use the new operator, this by default will point to the global object, which is window. So if I want to rewrite this expression in this way, instead of passing an empty object, I would pass window. Of course, we don't want to do this. I'm just explaining to you what happens under the hood. So let's revert this back. So the first argument here specifies the target of this. Okay. Now we have another method called apply. It's exactly like the call method. With this, we can call a function, but instead of passing all the arguments explicitly, we pass them in an array. So this is useful if you already have an array somewhere else in your application and you want to pass that array as the second argument to the apply method. So this is the takeaway. In JavaScript, functions are objects. Hi guys, Mosh here. Thank you for watching my YouTube tutorial. I just wanted to quickly let you know that this video you have been watching is actually the first hour of one of my courses called Object-Oriented Programming in JavaScript. So when you get to the end of this tutorial, if you feel like you want to learn more, click on the link in the video description and enroll in the course. And if not, that's perfectly fine. Continue watching as the next section is coming up. In JavaScript, we have two categories of types. On one side, we have value types, also called primitives. On the other side, we have reference types. So in the value types category, we have number, string, boolean, symbol, which is new in ES6. We're going to look at that later in the course, as well as undefined and null. These are the primitive or value types. On the other side, we have objects, functions, and arrays. So in the last lecture, you learned that functions are also objects. The same is true about arrays. So in a nutshell, in JavaScript, we have primitives and objects. Now in this lecture, I'm going to show you how primitives and objects behave differently, because this is absolutely important for you to understand before we move on to the next section where I talk about prototypes. So on this empty canvas, I'm going to define two primitives, x and y. I'm going to set y to x. So here y is 10. Now I'm going to change the value of x to 20. What I want you to note here is that x and y are two independent variables. So let's save the changes, go back in the console. Let's log x is 20, and y is 10. They are independent. So when we work with primitives, this value that we have here is stored inside of this variable. When we copy that variable, that value that is stored in the variable is copied into this new variable. So they are completely independent of each other. Now let's see what happens if we use a reference type or an object here. So I'm going to change this to an object that has a property called value. And then instead of setting x to 20, I'm going to set x.value to 20. So save the changes. Back in the console, let's log x. So you can see value property is 20. Now let's log y. You can see the value property of y is also 20. So this is the takeaway. When we use an object, that object is not stored in this variable. That object is stored somewhere else in the memory, and the address of that memory location is stored inside that variable. So then when we copy x into y, it's the address or the reference that is copied. In other words, both x and y are pointing to the same object in memory. And when we modify that object using either x or y, the changes are immediately visible to the other variable. So here's the conclusion. Primitives are copied by value. Reference types or objects are copied by the reference. Let's take a look at another example. So I'm going to define a function called increase that takes a number, and here we simply increase this number by 1. Let's declare a number variable and set it to 10, and then call increase and pass this number. Now, if I log this number on the console, what do you think we're going to see? Let's have a look. So save the changes. We see 10. But didn't we increase the number? Well, when we call increase and pass this number variable, its value is copied into this parameter that is local in this function. So this number variable here is completely independent of this other number variable. Here in this function, we increment number by 1, so it will be 11. But after this function, this number is going to go out of the scope. So when we log this number on the console, we're essentially dealing with this first number. So I told you that primitives are copied by their value. So here we're dealing with two independent copies. That's why we see 10 on the console. Now let's change this to a reference type or an object. So I'm going to change 10 to an object that has a value property. Okay, let's rename this variable to object. And similarly, I'm going to rename this parameter in this function to object, and then increment object.value. Now, when we log this on the console, what do you think we're going to see? We're going to see 11. See? We got this object with value 11. The reason for this is because when we call increase and pass this object is passed by its reference. So this local parameter that we have here will point to the same object that we defined here. So in this case, we are not dealing with two independent copies. We have two variables that are pointing to the same object. So any changes we make to this object will be visible to the other variable. So remember this. In JavaScript, we have value types, also called primitives, as well as reference types, which are objects. Our primitives are number, string, boolean, symbol, undefined, and null. Primitives or value types are copied by their value. Reference types or objects are copied by their reference. All right, so here we have our circle constructor function, and using that, we create a circle object. Now, these objects in JavaScript are dynamic. That means after you create them, you can add extra properties in them or delete some properties. You may be wondering why this is useful in the real world. Imagine you're working with a user object. The client, that can be a web or a mobile application, is going to send a user object to the server. On the server, we get this user object, and then we add additional stuff to it. For example, we can add a token property that we generate on the fly on the server. So we can always add something extra to an existing object. Because we don't have classes, we don't need to define these properties ahead of time. We can add them whenever we need them. And this makes JavaScript extremely powerful and easy to work with. In languages like C# or Java, every time we want to implement scenarios like this, we have to go back and change our classes. So here, let me add a new property to our circle object. We can set the location here like this. Save the changes. Now here on the console, let's log circle. All right, you can see here we have two properties, location and radius. We also have another notation for accessing properties, that is bracket notation. So another way to rewrite this code is like this. We use brackets and use a string to reference a property. So location. It's exactly the same. As you can see, the dot notation is simpler and less verbose than bracket notation, but this notation is also useful in certain scenarios. For example, when you want to dynamically access a property name. For example, let's imagine we have this constant called property name set to location. We have that somewhere in our application. Now we want to access the location property of a circle. If you're dealing with this dynamically, at the time of writing the code, we don't know what is the name of that property. That is calculated at runtime. So we can type something like this, circle.location. But what we can do is use the bracket notation. So we use circle, brackets, property, name. Another use case for using the bracket notation is when you're using the property names that are not valid identifiers. For example, let's imagine the name of this property is center-location. We can access this property like this, circle center-location. That doesn't work. So if you have special characters or a space, that's when you use the bracket notation. Okay? Now we can also delete a property from an existing object. A real-world use case for this is when you get a user object from a database and you want to return it to the client. But maybe that user object has certain properties you don't want to send to the client. You don't want to send the password, you don't want to send the credit card info. In that case, you will dynamically delete one or more properties from an object. So we use the delete operator and then reference the property name. So circle.location. Again, here we can use the dot notation or brackets. And of course, here we need a string. Sometimes you need to iterate over or enumerate the properties in an object. We can do that using the for in loop. So for let key in circle. So in every iteration, key will hold the value of one key in this object. Let's log that on the console. Okay, so look, we have radius and draw. So it's returning both properties and methods. Now, if you want to get the value of these properties, you can use the bracket notation. So here in console.log, I'm going to log circle of key. You learned in the last lecture that we can use the bracket notation to access a member. Okay, so save. Now we can see radius is 10 and draw is a function. What if we want to get only the properties and not the methods? Well, we can use the type of operator to check the type of this value. So if type of circle of key is not equal to function, then we will display it on the console. Save the changes. Now we get only the radius. There is another approach to get all the keys in an object. So this object that we have has a method called keys. We can pass our circle object here, and this will return all the keys in the circle as an array. So let's store them here and log them on the console. So here we have an array with two members, radius and draw. With this approach, you cannot separate properties from methods. Now finally, sometimes you want to know if an object has a given property. For that, we use the in operator. So if, here we add the name of the property as a string, if radius is in circle, we do a console.log of circle has a radius. Okay, save the changes, and here's our message. So remember, to enumerate all the members in an object, you can use a for in loop. To get all the keys in an object, use object.keys. And to check for the existence of a property or a method in an object, use the in operator. All right, now let's introduce some complexity in this example. So I'm going to define another property called default location, set it to an object like this. Also, let's define another method, compute optimum location. We set this to a function. And here we're going to do some magic. It doesn't really matter. What matters is that we're going to call this method inside of the draw method. So we call this dot compute optimum location. Now there is a problem with this implementation. Let me show you. So here, when we create the circle object, circle dot, these are the members of our circle object. Not all these members should be accessible to me as the consumer or the client of this object. For example, what would happen if I set default location to false? That's going to completely mess up with this object. Or as another example, maybe this compute method should only be called inside of the draw method. So if I accidentally call it here, circle.compute optimum location, maybe this will put this object in a bad state. And then if I call circle.draw, we're going to get a weird error at runtime. So in object-oriented programming, we have this core concept called abstraction. Abstraction means we should hide the details and complexity and show or expose only the essentials. In this particular example, we should hide this property, default location, as well as this method. These are implementation details. These are part of the complexity of this object. We want to hide these from the consumers of this object. Instead, we want to expose only the essentials. That is the radius and the draw method. Let me give you a metaphor. Think of a DVD player. A DVD player has a complex logic board on the inside, but only a few buttons on the outside that you interact with. So what we have on the inside is the implementation detail, and what we have on the outside is the public interface of a DVD player. We want our objects to look like this DVD player. We want to hide all the details, all the unnecessary complexity on the inside, and expose only a few members or a few buttons on the outside. A lot of developers who have not been able to apply object-oriented programming effectively have failed to comply with this principle. Everything in their objects is public and accessible from the outside. And this will bring a number of issues. One issue is that every time you change the implementation of that object, you have to go and modify many different places in your code. For example, let's imagine now this compute method requires an argument. Let's add a factor argument here. With the current implementation, because we can access this from the outside, everywhere we have used this method, we have to come back and pass an argument. So one simple change in the implementation of an object results in a number of changes in your source code. In contrast, imagine if this method was not accessible from the outside. Then we wouldn't have to modify this line. We would only modify line 12, where we have called this function, right? So remember the abstraction principle of object-oriented programming. Hide the details and expose only the essentials. In the next lecture, I'm going to show you how to implement this in JavaScript. So how do we implement abstraction here? You want to hide certain members from the outside. So earlier you learned that this references that new circle object. Now what happens if I declare a local variable in this function? Let's say color, we set that to red. Is this going to be part of that object? Of course not, because we have not set that as a property on that object. We didn't set this.color to color, okay? So this is only a local variable inside of this function. When we get out of this function, this variable goes out of scope and dies. Now with this technique, we can easily hide certain members from the outside. So default location is implementation detail. We don't want this to be accessible from the outside. Instead of setting it as a property on our new object, we define it as a local variable here, okay? Now we don't need this color anymore. By the same token, we can convert this method to a private method. So let compute be a function. Now, here in the draw method, we're calling compute optimum location. This function will no longer be a method on this new object, so we can access it using this. We have to access it directly here. This will work because in JavaScript, we have this concept of closure. If you don't know closure, let me simplify it for you. So here we have one function and another function inside of that function. In this function, we can declare certain variables like x and y. And these are local variables that are only available in this function. Their scope is limited to this function. So when we finish executing this function, x and y will go out of scope. In contrast to scope, we have closure. A closure determines what variables will be accessible to an inner function. So this function will be able to access all the local variables defined here, as well as the variables defined in its parent function. So here we declared two variables, compute optimum location, which is a function, as well as default location. These are the variables that are defined in this parent function. They are within the scope of this function, but within the closure of this inner function. Now, don't confuse closure with a scope, because the scope is temporary and it dies. So every time we call the draw method, these variables will be recreated and reinitialized. And then after this function, they will die. So scope is temporary, but closure stays there. So when we call the draw function, after we finish executing this function, these variables will continue to stay in memory. They will preserve their state because they're part of the closure of this draw function. Okay, so back here. So in this method, if you want to access those private members, you simply use them here. You can also use default location. But if you want to access members of this new circle object, you need to use this. So this.radius as an example. Okay, now with this simple change, we basically replace this with let. Let's see what happens. If we access the members of the circle object, we only see draw and radius. So the public interface of this object is simpler, is easier to work with, and this will also prevent issues later down the road. So in the last lecture, we converted these two members to private members. Now, more accurately, these are not private members of the circle object because technically they are not inside of a circle object. They are local variables that we have defined inside of this circle function. But from an object-oriented point of view, we can refer to them as private members of the circle object. Now, I want to simplify the code here so we can focus on a small issue. I'm going to delete this compute function, right? So we have this private property, default location. We cannot access this from the outside. But what if we want to display that default location somewhere in our application? So we don't want to modify it, we just want to be able to read it. So one solution is to define a method here, this.getDefaultLocation. We set it to a function. And in this function, we simply return default location. Once again, we're dealing with an inner function here. The closure of this function includes all the variables defined here, as well as all the variables defined in its parent functions. So here we have access to default location. And with this, we can call circle.getDefaultLocation. However, I don't like this syntax. I don't like the fact that we're calling this as a method. It would be nicer if we could access this property like this, default location. But we shouldn't be able to set this from the outside. We can only read it. So let me show you how to define a property like that. So this object that you have seen so far has a method called defineProperty. We have another method called defineProperties if you want to define multiple properties in one go. Now, the first argument to this method is the object that we want to add a new property to. That object is the one that is referenced by this, the new circle object, right? So we pass that here. The second argument is the name of our property. We want to call that default location. And the third argument is an object. In this object, we add a key value pair. The key is get. This is a special keyword for JavaScript. And the value is a function. So when we access circle.defaultLocation, this function will be called. Okay. Now here we can simply return default location. Again, this variable is part of the closure of this inner function. So here we can access it, right? Now in VS Code, you don't see that in IntelliSense. So we don't have default location as a property. However, if we save the changes, oops, I made a mistake here. Actually, I should have used define property. So save the changes. All right. So now look at the circle object. Circle. So here's our new property, default location. You can see dot, dot, dot in front of it because this is a computed property. When we click this, that get function will be executed, and here's the result, our default location. Okay. Also, you can see that function is stored here as a getter. So a getter is a function that is used to read a property. So this property we have here, default location, we refer to this as a read-only property. Now, if you want to set the value of this property from the outside, we define a setter. So in this object, we add another key value pair. The key is set, which is a special keyword, and the value is a function. Now this function takes an argument called value. We can set this default location to this value. But what is interesting is that because we are using a function, in this function, we can perform some validation for this value before setting the default location. For example, we can write a simple logic like this. If value.x is falsy or value.y is falsy, we can throw a new error. Again, error as a built-in constructor that we use to create error objects. We pass a string invalid location. So this is the benefit of a setter. Now we can come here and set circle.default location. Let's see what happens if we set this to 1. Save the changes. And here's our error, invalid location. So to recap, use object.define property to define getters and or setters. All right, here is a great exercise for you. I want you to use what you have learned in this section and design a stopwatch object like this. So let me show you how this behaves. I'm going to define a constant called SW and set it to a new stopwatch. So that's our stopwatch object. Now, this object has a few members: duration, which is a property, as well as 3 methods: reset, start, and stop. And the other members you see here, they are inherited from the base object, okay? Now, initially, duration is 0. We can start the stopwatch. Now, at this time, if we call start again, it's going to scream at us. Stopwatch has already started, so we cannot call start twice. Now we can call stop, and again, we cannot call stop twice in a row. It's going to complain because stopwatch is not started. Now we can access the duration property. So stopwatch, So stopwatch dot duration. So this stopwatch counted 19 seconds from the moment I called the start method until I called the stop method. Now we can repeat. So if we call start again, now it continues counting, and then we call stop, and then let's look at the duration again. Now it's a total of 20 seconds. We can also call reset, and this takes the stopwatch to its initial state. So we can call start, and then stop, and then look at the duration. Only 2 seconds, okay? So this is how the stopwatch works. Now I want you to go ahead and spend about 30 minutes on this exercise. Use what you have learned and do your best to implement an object that behaves like this. In the next lecture, I'm going to show you my solution. All right, here's my implementation of the stopwatch object. Now, don't worry if your implementation is different from mine. Chances are it's going to be different because there is no one solution to a given problem. As long as your stopwatch behaves like what I showed you in the last lecture, and it has a clean implementation, your solution is perfectly fine. So here we have a function called stopwatch. This is a constructor function. I have defined a few private variables here: start time, end time, running to see if the stopwatch is running or not, and duration, which I have initially set to 0. You can see we have 3 methods here: start, stop, and reset. And I've also defined a read-only property called duration. Look, here we have a getter, which simply returns this duration, which is a local variable in this function. Okay, now let's take a look at the implementation of each of these methods. So start. First, we have a validation check. If the stopwatch is running, we simply throw a new error with this message: stopwatch has already started. Otherwise, we set running to true and set start time to the current date time. Very simple implementation. The stop method is very similar. So first we have a validation check. If it's not running, obviously we cannot stop it. That's why we throw a new error. Otherwise, we set running to false. Next, we set end time to the current date time. And then we calculate the seconds between the end time and start time. So we call end time.getTime and subtract it from start time.getTime. This expression returns the milliseconds between these two date objects. So we divide it by 1,000 to get the seconds, and then add that to the duration variable which we defined earlier. And finally, let's take a look at the reset method. Here we simply set these variables to their initial value. So we set start time and end time to null, running to false, and duration to 0. So once again, if your implementation is different, don't worry. There is no one best solution to a given problem. If I come back and solve this problem in a month from now, chances are my implementation is going to be different from what you see right now. Well, hello, it's me, Mosh again. I wanted to say thank you very much for watching this tutorial to the end. I hope you learned a lot. Please share and like this video to support me. If you want to learn more about object-oriented programming, as I told you before, I have a course called Object-Oriented Programming in JavaScript. This video you have been watching is the first hour of that course. If you want to learn more, click on the link in the video description and enroll in the course. And if not, that's perfectly fine. Make sure to subscribe to my channel because I upload new videos every week. Thank you and have a great day.